Welcome to AdaptNow, the ABB podcast series on adaptive execution. So hello, everyone. This is Dan Oberle, and today we have Brian Loos, who comes to us from Canada. Welcome, Brian. Hello.
Hi, Dan. Thanks.
Maybe you can start with telling everyone a little bit about your background.
Sure. Yeah, I'm an electrical engineer. I've got about 34 years of experience with process control, automation, safety projects. The last 21 years I've been with ABB. I've had opportunity to work on a number of projects in different industries: oil, gas, and chemicals, pulp and paper, mining, and so on, and in different roles: engineering, commissioning, even engineering and operations management. And since 2012, late 2012, I've been a project director for large projects at ABB.
So, Brian, to begin with, I'd like to ask you a little bit about the history that got us to this point, and maybe you have some anecdotal stories about the way you used to do projects before ABB Adaptive.
Sure, yeah, a couple of examples come to mind. One is around, the traditional, what we call the I/O cabinets with the predefined or pre-configured I/O card types, multi-channel pre-configured I/O cards. And typically we would build cabinets that had terminal blocks on one side and the pre-configured I/O cards on the other side. And then we would build a lot of marshalling or cross-stitching wiring between the terminal blocks and the pre-configured I/O cards to map onto how the field cabling was designed, these home run cables that would come in. And typically we had to start that work early in the schedule to be able to deliver the cabinets to the fabricator so that they could do their field wiring. And what usually happened is you started working with early data, preliminary data. So we built in spare capacity and we built in design development allowances. And then we would engineer these cabinets, which was usually extensive, a lot of drawings per cabinet, a lot of details on all the cross wiring was put together. And we would build these cabinets and we would test these cabinets. And normally right about the time we'd be getting ready to ship these cabinets, the process design has been maturing during that period of time. And things start to change in the I/O signals. Mm-hmm. Quantities change, type of devices change. And that meant we had to make changes to that marshalling wiring. So just as you're getting ready to either go into the acceptance testing or you're ready to ship, we get what's called a mod pack. And so we'd have to engineer the mod pack, create the drawings or modify the drawings for the cabinet builder, and they would have to make all the changes.
Okay.
And then historically, it would happen again when the cabinets were at site. And so all of these little mod packs had to be incorporated into the field.
Okay. So you basically had to wait for certain things and you were dependent on other things in the process that you couldn't control and
Yes.
I see. Okay, so then the modern way led us to the adaptive. So ABB Adaptive, we know, is a methodology, it's a philosophy, it's an approach, a new approach for ABB taking on large projects. And maybe you can start with explaining your background, like what did projects used to be like before ABB Adaptive?
Yeah, I think if you look at historically how projects were executed, they were done in a more sequential fashion. People call it serial or waterfall type. But over the course of the years, the projects have changed. Many more. It's much more global. Schedules are tighter. There's a lot more parties involved, and it's gone to a very modularized approach. And so the adaptive, I think, really reflects how ABB has changed the traditional integrated control and safety execution method to align with that. A couple of things that stand out for me. What we used to have was a traditional design freeze. It was a single design freeze where we tried to freeze the design and then, start the engineering and the fabrication of the equipment. But what's happening nowadays is that different areas of the design mature at different points in the schedule. And so adaptive recognizes that and it makes adjustments. The other thing you see, and it's a fact of life with these kinds of projects, is even when the designs have matured sufficiently, we know that there's always late cycle changes. And that's just a fact of life in the current climate. because the automation side of the project is so heavily dependent on all the other disciplines in these large capital projects. You have a number of package equipment suppliers involved, and there's plenty of interfaces between the integrated control and safety system and the package equipment suppliers. So it's hardwired interfaces, soft-wired interfaces, and all of that information, again, matures very, very late in the schedule. Then you have a lot of process module fabricators, because we've gone to very modularized solutions where pieces of equipment or pieces of the process are built in large fabrication yards. Those fabricators need equipment to meet their schedules. They need cabinets, they need enclosures and so on. So we were always trying to find a balance. You don't want to build the hardware too early in order to meet the fabricator schedule, because if you ship it too early, you wind up doing a lot of rework in the field. So the whole idea behind adaptive is to some things that alleviate some of those issues, and the objective is to keep the automation system off the critical path.
Can you think of anything that what prevented us from going this path sooner, or can you think of breakthroughs in technology perhaps that sort of allowed us to get to this point?
Yeah, a lot of the way projects were executed was dependent on the technologies that we had at the time. And so what's happened recently is a couple of key technologies have happened that really make it possible to adapt to the way projects are unfolding. I think the first one is the ABB single channel select IO. It has the ability to use the term marshal or assign IO channels to multiple controllers through software connections. And historically, we used to do that through hardwired cabling connections. And so when marshaling schedules or when signals had to move between controllers, it meant wiring changes. And normally those wiring changes happened when you were in the field. And that was always costly and time consuming, and it rippled back through the entire process. So that's really made a difference. I think the ability to use the virtual cloud environment. So we create a virtual version of the control system hardware and software in a cloud environment, and then we use that for the development and testing of the application configuration, including the customer acceptance testing and the witness testing. So you've really separated out the hardware, which we used to build the hardware and use that for all the application development. Now we can do all the engineering work in this virtual cloud environment, and then keep the hardware on a separate path. And I think that the third thing is really that the industry's push and suppliers push to standardize hardware and software solutions. And of course, the engineering tools that are built around those standard solutions. So those kinds of tools allow you to automate the generation and the testing of the application software. So things like operator graphic displays, the controller configuration, cause and effect logic for safety, and so on. If you've got standard tools, standard templates, you don't have the time and the effort and the translation risk for key punching. So that's had a big impact as well. And it's really, I think, the industry acceptance of let's work with standard solutions rather than try to customize everything.
Yeah, some of my experience was the pushback towards those standards was more about process knowledge, and customers always looked at it as we have the special application that was unique. So have they had to adapt themselves to this?
Yeah, I think customers are realizing that if you can take something that's standard, you can eliminate a lot of the steps. If you have a standard, we'll say a smart junction box that is standardized, then you don't have to go and do witness testing for each of those. You can create one set of documentation that covers all of them. And you think about the time and effort that used to go into customer witness testing when we had customized marshalling cabinets and all of the cross wiring that was associated with that. It was a lot of time and effort. You think, a typical project one that I was involved in, we had about 120 cabinets, and 70 of those cabinets were what we call marshalling cabinets. This is where all the field I/O landed. And they land the I/O on terminal blocks on one side of the cabinet, and then they do cross-stitching wiring between there and what used to be the old I/O cards that had multi-channels. Mm-hmm. And that was a tremendous amount of effort to engineer tremendous amount of effort to build, and then a tremendous amount of effort to test and validate. And then if you had changes, well, it started rippling through the entire system. So customers have said, hey, you know what, if we can take something that's standard and we can eliminate a lot of witness testing, if we can eliminate a lot of documentation that we don't have to review and make comments on and process, there's some savings to be had. Same thing on the application work as far as how the graphics look and so on. Customizing that all takes time in your schedule, and there's a cost.
Yeah. Can you explain, you say the standard cabinet, so can you talk a little bit about changes in the I/O configuration, signal lineup, things like that? How do you do that now?
Historically, we'd have what we call multi-channel I/O cards for process control and safety, and it would be 16 analog input channels or 8 analog output channels per card, and they were predetermined. Mm-hmm. We've gone now to this single channel select I/O, where you can build an empty junction box. We call them a smart junction box, and then we can insert individual personality or single channel modules that determine what that field device is. Mm-hmm. And so if you make a change to that, you only make the change to that one single channel item. Mm-hmm. And because you put these smart junction boxes out in the field and you bring the field wiring directly in to these smart junction boxes, you no longer have all of that marshalling or the cross-stitching wiring that used to be required. Mm-hmm. So it makes it very easy to not have to worry about a lot of the I/O design up front. The other thing is because we can make marshalling changes through software rather than physical cabling.
Right.
We can move signals between controllers relatively easily with just a software change, as opposed to having to unterminate cabling and move it over to another location.
Yeah, and I would think the typical factor of 20% extra I/O or things like that you would do with the modular design, you can just expand if there's changes in the process that require more.
Yeah, I mean, with these smart junction boxes, we make them in predefined sizes, 48 in a box or 96 I/O in a box. And then if a customer starts off and says, we've got 3,000 I/O signals on this project, we ship them, 30 100 I/O boxes. And if they need more signals, then they just add a couple extra I/O boxes. Mm-hmm. So you don't have all of that built-in spare. You don't need all that built-in spare capacity for spares and for design development. If you need more I/O, you just buy these very easy to build off-the-shelf type boxes.
Mm-hmm. What about during the commissioning of a project? Have you got anything you can share with the audience on that that's different?
Yeah, one of the things that we've got, by using the cloud for the engineering environment, the virtual engineering environment, we really separated out the hardware and the software. And they can run on their own schedules now, which historically wasn't the case. But now that they run on their own schedules, we can ship the hardware cabinets and these smart junction boxes to the fabricators whenever they need them. And, we can make them relatively quickly. They're off the shelf. We send them to the fabricators and they can install them and they can start terminating their field wiring. And while the rest of the application software work is continuing on in that cloud environment, mm-hmm. the development, test, and so forth.
What about like loop checkout?
Yeah, so then the fabricators, they can either have a predefined subset of these single channel modules and just move them around, and they can do their loop checking without all of the infrastructure and all the overhead that you used to have for a controller, operator console, and an engineering workstation. We've got something called the Ethernet Field Toolkit, and you can plug that. It's basically a laptop. Plug it into one of these smart junction boxes, and you can do loop checking and commissioning of all the signals connected to that junction box. When that's done, now you've got the as commissioned version of the I/O signal database for that junction box. We just bring it back and we integrate it back into the engineering application that's in the cloud environment.
So what does a modern factory acceptance test look like? Is there one?
The modern factory acceptance test has changed. For a lot of the things from a standards perspective, standard I/O cabinets and controllers and so on, they really don't need a lot of witness test. I mean, all that they're built, they're tested internally, and then they're delivered like a product. The application configuration work, historically we used to bring a team for large projects. We'd bring a team from ABB, we'd bring people from the engineering company, and usually the client into what we called a staging location. And everybody would get together and they would do a complete integrated test of all of the software on the target hardware. And for large projects, that could take 6 months or more. It wasn't uncommon for a team to be sitting in one location for 6 months or more. Very expensive, time consuming, and I mean, in today's COVID-19 situation, really tough to get people into certain locations. So now with it in the cloud, everybody can stay in their home locations. They can work from where they are, whether it's at home or in their own local office, because everything's in there and it's accessible to the entire project team. Mm-hmm. So we do that, and all of the acceptance test, the witness test, and so on for the software application is done that way. Okay. We've even had projects where we've melded in the process modeling for the operator training simulator and used that as part of the overall factory acceptance test.
Okay.
And because it's distributed, it's global, you can work. I mean, the only challenge you have is the time zones.
Okay. Well, this is great information, Brian. Maybe we can just sort of wrap things up with your thoughts on the impact on cost, schedule, risk for our clients. So the benefits to the clients in those three areas. This new methodology, adaptive methodology, how can you summarize the value of cost, schedule, risk in the modern project execution model?
Yeah, sure. I think from cost perspective, anytime you take things that are off the shelf standard and you deploy them, it saves an awful lot of time and effort up front having to customize. If we accept that this is the standard, it works, it's field proven, it takes time out of the schedule, and it's also less costly. Mm-hmm. From a schedule perspective, the thing we do by standardizing and then using tools that are built based on those standards, we can wait until later in the process to do the bulk generation of the configuration. So we basically can start later when the design is more mature.
So it's more predictable.
From a risk perspective, the ability to, with a single channel I/O, to be able to make late changes easily. So for example, if you're in commissioning or you're in startup and a number of signals have to move between controllers, it's a software change as opposed to having to terminate wiring and move wiring. If you find some more I/O, which most projects do as they progress, all you do is you just add more of these single channel modules where you need them. And it's very simple. You just land the field wiring right on those. So those are the big things, I think, because late cycle changes are really a fact of life for automation, and some of these technologies and approaches give you the ability to absorb those with minimum impact.
Yeah, and it sounds like some of the things that would be a lot of human interaction that would take place in the past are eliminated, which obviously reduces risk as well. So that's exciting stuff, and I really think that that I know this is the first podcast that we're starting off with, but it's exciting to hear ABB doing this, and really appreciate you coming out today and talking to us to kick this new technical series off for ABB Adaptive. So thanks a lot, Brian. And
thank you. I enjoyed it.
You have a great day.
You too.